All right, scholars, we're working on chapter 3. It's all about lines and angle relationships with lines in chapter 3. Today is heavy definition day. All right, are you guys with me on that? And some basic, actually it's just a heavy definition day. There we go. Note cards galore. Did everyone hear me? If you're a note card person, this would be one of those days. But it's the basis of what we do throughout the rest of the year in geometry. Kind of like how I told you that midpoint we'll use till the end of time, right? Vertical angles we'll use all the time. We'll use tons of vertical angles in here as well. Linear pair we'll use a lot. These terms and stuff we use throughout all of geometry. So it's really important that you guys have them down. So today is all about definitions, making sure we're on the same page. Now, if you notice, it's a lot easier to see this diagram in color. You guys with me on that than what's on your paper? So try to make sure you're transferring down, rewrite things if it's a little bit harder to see. But really what you see there is basically a three-dimensional cube. Are you guys with me on that? Where we take and we actually extended the sides to be lines. And of course, the sides of the cubes, we'd call those planes. Everyone with me on the same page, right? All right, so let's go ahead and let's start filling this in. This is some things that a lot of you actually already kind of showed that you knew. First of all, parallel lines, notation you need to know. You're either going to see literally two parallel line segments next to each other, or if people don't want them to look like L's, you'll see math teachers slant them sometimes. I go straight up and down with mine. But like if you were in Mrs. Prempus's class or Mrs. Young's class, they will slant theirs. It's just a preference of the teacher. Now, what is the definition of parallel lines? Here's the key word people will forget, but it's important that you need to know. They have to be coplanar. So it's coplanar lines that never intersect. Now, do you guys remember how you had on your quiz that you had to give a counterexample? What type of lines did you show me in that counterexample? Parallel ones. A lot of you drew them and said, look, I can show you that lines don't intersect. You didn't even call them parallel, but some of you are like, lines don't intersect sometimes and they're in a plane. And it was a great counterexample where you're showing parallel lines. Now, there's a few things you need to know about notation. You know how we have like congruency symbols? We also are going to have that for parallel. So like up above, you're going to see something like this. We know that line AB is parallel, notice the symbol right there, to line EF. Notice what's drawn on each one of those lines. Do you see the tick mark? They both have an arrowhead going the same direction. Anytime you see a tick mark like that, an arrowhead going the same way, you know that they're parallel, that they lie in the same plane and they will never intersect. Do you guys see another pair that's been marked for you? We have line what? Yeah, we had line EG. Make sure I make that. G is parallel to line FH. And now notice, since they're not parallel with the other two, I have two arrowheads on that. Now, is that very similar to how we'd mark congruency up, right? So we need to make sure that we know those. All right, another term that you know, and that I've even used with you, but we haven't spent a lot of time on, is the word perpendicular. Anytime when someone says perpendicular, how would you put your arms real quick? If I said perpendicular, show me what would you do with your arms if I said, give me perpendicular. A lot of you went like this, right? What type of angle am I forming with my arms? Yeah, 90 degrees. So when I have perpendicular lines, they're lines that intersect at right angles. So let's write that down, their definition. Lines that intersect at right angles. Notation for that, an upside down capital T. It's two line segments that are what to each other? Perpendicular. So that's notation that you need to know. Now think of it like this. We've been using this already with coordinate planes and everything. Here's your X, here's your Y. But if you know it's a coordinate plane, you're going to have 4 right angles. If I have 1 right angle marked, vertical angles and linear pairs tell me all of them are going to be right angles. So anytime that you have perpendicular lines, they're just lines that intersect at right angles. So in the diagram above, you can never assume right angles unless it's marked that way. Are you guys with me on that? So on there we have a couple right angles marked. So you guys see this one right here. Over here at angle EGH. Well, if that's the case, that means then that line EG is perpendicular to line GH. Now we have another one too. Do you guys see it up here at A? So that would be, which ones then? Line AE is perpendicular to line AB. Now those are the only ones I can assume based off of what I know, because those are the ones that are marked. So do not tell me it's a right angle unless it's marked a what? Right angle. Excellent. Or I tell you it's perpendicular. Then you can go there. All right, skew lines. Now, skew lines are a little bit different. This is a lot harder for a lot of people to get down. There is no notation for this, but listen to the definition. Skew lines are non-coplanar lines that never intersect. Because think about this in this world, guys. Look at the ceiling over here and the wall with the whiteboard. Do you guys see the line going right here? Where they intersect? Because when two planes intersect, they intersect at a line, right? So my two planes intersect, there's my line. I have this, my pin now is another line. It's going like this. The plane's going this. Are they ever going to intersect each other? Here's the pin going this way. There's the line going this way. Are they ever going to intersect? No. Could I have another one that misses it? Like one that goes over it? Yeah, it's basically, I was like, it's like the two airplanes when they're flying, right? You see them, one, it looks like they're going to intersect, and all of a sudden you realize one's like another mile above the other one. They pass over each other and they cross, and you see, what do you call the gas that's coming out? There was it the trails, whatever those called. You know what I've been talking about, like the exhaust trails. There's a really cool name, and I can't remember it at this moment, of course. All right, but anyway, they cross over each other. They're never going to intersect each other, but they're definitely, are they in the same plane? No. How about if I have one, my arm going right here and my other arm going right here? Are those in the same plane? No, they're not going to intersect. So what would be some cool examples here? How about this one? You guys see this line right here, line FH. Now I want you to look back. And I'm going to do line CW over here. Actually, I didn't want to use that color. Try it a little bit different. See line CW? FH is the front corner, and line CW is the bottom back. One's going vertical, the other one's going horizontal. Are they ever going to intersect? No. So we can say then that we know line FH and line CW are skew. So think passing over each other. That one could like go over, but they would never touch. Yes?
They like to call the parallel lines skew lines?
Well, no, because what's the definition difference right there? That's a good question.
Okay.
One has to be what? Coplanar, and the other one's what, guys? Non-coplanar. The question was, can I ever call parallel line skew? Can I? No, because then it doesn't fulfill the definition. Great stuff. All right, then the next one's kind of common sense. I'm not too worried about you guys knowing this one. It's the idea of parallel planes. Now, we're still going to use the word parallel and symbol notation for parallel with this. But think about parallel planes are just going to be planes that what? They look like they're like stacked up on top of each other, right? Like a stack of paper. So we're going to say there are planes that never intersect. So looking at this diagram, even though I didn't do a great job of drawing it here, but would you say that the top and the bottom would not intersect each other? Like on a box? Yeah. So on this one, we're going to say plane. How many points do I need to say, name a plane? What type of points? Collinear or non-collinear? Non-collinear. Awesome. So we have here, I'm going to go ABE is going to be parallel to plane CGW. All right. Ignore that for right now. All right. Now, let's keep going for the next ones. It says identify each of the following. Now, this one's a little bit different. Yes, sir.
Is there any difference between the parallel notation for planes and lines?
You can't use arrowheads to show that they're parallel. You're just gonna have to state it for planes. But otherwise, no, it's just the parallel symbol. That's the cool part about one. There's not a lot of new stuff with it. All right, so with this, my friends, Let's see if you can identify these quickly for me. I need a pair of perpendicular lines. Holly, you got this one for me? Okay. Anyone got a pair of perpendicular lines for me on this one? Luke? Very good. So it'd be, if I ask for lines, guess what I want you to give it to me as? Even though they drew it as a line segment, if I ask for lines, give it for me as lines. Remember, we're trying to show it finitely on this. A pair of parallel planes. Oops, we can do perpendicular here. Thank you. Makes it easier. Pair of parallel planes. Michael. You mean plane ABC? It's parallel to plane EDF. Excellent. Remember, correct notation for a plane. Do I have to write the word out, my friends? Yep, we do. All right, I need a pair of parallel lines. A pair of parallel lines. Katie. Yeah, that totally works. So line BE is parallel to line CF. Now, could I have also on here, maybe I did like line CF is parallel to line AD. Would that be okay too? Yeah, because they have the same arrow marks, so we know that they're parallel. And they lie in the same plane. Yeah, or you could do like CF and VE together. I mean, you had your options on there. Here's the ones I want to give you. Make it easy on yourself. Go with the obvious answers. Did everyone hear me on this? Go with the obvious ones. There's ones that look like they might be parallel too, but if we don't mark it, are you absolutely certain? No, so just be careful. All right, a pair of skew lines. A pair of skew lines. What do we got for this one, Hallie?
Line EF.
You said line EF, and which one? AD? Yep, very good. So line EF, if I can draw my arrows better. EF and line AD. Good. Kind of like they're passing over each other, right? Did anyone have a different pair of that? I saw some other hands up earlier. Anyone else have some? Josh, do you have one more?
It was just AB, line AB, and line CF.
Yeah. Line AB is almost like the same idea, isn't it? You said EB and which one? BC and AD? Oh, yeah, totally. Oh, ED? ED, and you said, yeah, totally, because one's going this way and one's going the other way, and they're never going to intersect. Totally would work as two of them. Excellent. All right. With a partner, basically the person next to you, fill in the next ones very quickly. And remember, answers may vary. All right. Perpendicular to. All right, I gave some examples on the board. Most of you are finishing up. Just making sure you used good notation. Remember, all of them have notation except for skew lines, right? Could you pick differently than me? Like parallel lines, I only named two. Like you could have like 4 different combinations here, I think. Could you have even said line BE and line GH? Are those parallel? Do they have the same number of arrowhead marks? And could I, let's put our imaginations in order here. Could I literally draw a plane connecting the top and the bottom corners? It'd go diagonally through, right? So that's definitely a possibility as well because they have the same arrowhead marks. You could do the vertical ones. A pair of skew lines, I just chose B, E, and GH, but I'm sure you guys chose different ones, and that's okay. I always just think, make sure one passes over the other. It just makes it easy. A pair of parallel planes, I just did the top and the bottom, CBD and plane GFH. However, please make sure you use correct notation because guys, will I still take off notation points if you don't use it correctly? Yes. And then a pair of perpendicular lines. I only gave you one right angle. That's the only one you can go for. Sounds like it fair? So we have working with it. Now, we have some other terms we've got to know when we're working with it. The first term is called a transversal. Okay, a transversal. Now, I didn't write the definition right there. For some reason, I totally didn't give space. So we're going to write the definition down here. Okay, what is a transversal? Yes, what's your question real quick? How many points do you need to name a plane? At least 3, right? So I'm just going to name it with 3, as long as there are 3 non-linear points. Yeah, totally. Yep, totally okay if you have 4 to name a plane. All right, so a transversal on this one. What is it? It is a line that intersects 2 coplanar lines in 2 different points. So it's a line that intersects 2 coplanar lines in 2 different points. So it's going to be coplanar with 2 lines, so we know that. It's going to be in a plane when you're working with it. And a transversal, I'm going to highlight the color here real quick for you, is in this case, in this diagram, it's going to be line T right here. Notice I have my 2 lines, R and S, right, that are in that plane. And then it says really 2 different points. You have to understand the transversal is going to go between the 2 of them. For some reason, hello, why are we not wanting to work pin? Here would be a point. Here would be the other 2 points. Are you guys with me on that? Now, there's some things you need to know about a transversal, some major terminology. When your transversal is between its 2 lines, you see the dark brown that I have here, and for you guys it's like a darker gray on your worksheet. That's called interior. So when I look at those angles, 3, 4, 5, and 6, those are interior angles. Now, on the outside, where the transversal keeps going and it's only really touching that one line and keeps going, the lighter, I had light blue, like a bluish gray on mine. So for you, it's just going to be the light gray on there, right? That is going to be called the exterior. So angle 1 and 2 is considered exterior, and angles 7 and 8 are exterior angles. It's all about location, location, location. It helps us identify things better. Transversals are going to be the key for this unit. Did everyone hear me on this? Knowing how to see a transversal. So with this one, we got angle pairs that are formed by transversals. This definition are huge. We use this. I throw this at my pre-cal students. Yeah. I'm like, you remember in geometry class? So remember, in 2 years, you got to remember what you learned, okay? Now, the first one's called corresponding angles. When you hear the word corresponding, doesn't that mean they go together? Like there's a correspondence between 2 people, like that we'd be communicating together. So there's some relationship between the 2. So what are these? There are 2 non-adjacent angles on the same side of the transversal, and one is interior and the other is exterior. All right, so we need to be working with this. And if you do it right, if you have 2 lines and a transversal intersecting them, you're going to end up with 4 pairs of corresponding angles. So work with me for a moment. Let's look at angle 1. You guys agree with me? Angle 1 is an interior angle, right? Now, I have to have non-adjacent angle, and it has to be exterior. So I have an interior and exterior. Angle 2, is that adjacent to angle 1? Is that true? So can angle 2 pair up with angle 1? No. The only other one exterior angle on the same side is angle what? Angle 7, right? Angle, now, same side of the transversal. That doesn't mean you cross over it. You don't go across the line, the transversal. This would be on the same side. Let me do it this way. We're going to do a little bit of highlighting fun. This is same side. This would be same side. Does that help a little bit with pairs of angles a little bit to give us a visual? So when I'm working with this, I know angle 1 and angle 4 because they're the non-adjacent angles. So angle 1, excuse me, angle 1 and angle 7 are corresponding angles. Now, guys, what's left for the two angles to correspond that are on the blue highlighted side? 2 and what? 2 and 5. So I got angle 2 and angle 5. All right, now let's do this next one. Can 3 and 6 go together? No, because they're adjacent. So what would 6 go with? 4, because that's the other interior. Good. So we got angle 6 and angle 4. Now, 3 and what then? 3 and angle 8 are your corresponding angles. Now, these make a rough F. Someone goes, Gregerson, you are totally like doing something insane. What do you mean rough F? If I look at 1 and 7, for instance, here's my transversal. Those would be my two lines that make it. Do you guys see? Actually, I don't like that blue here. This blue right there. Basically, if I was to talk about forming the angles, you see that blue upside down F? It should be a boxy F. If you're making them, it could be upside down, sideways, but it should make a boxy F, and they're on the same side. Like when an F makes it, you have your two lines coming off of it. I wish I knew grammar better than this to describe how to make a letter F, but it's on the same side. All right, we got to keep going. All right, next term. Like I told you, today is heavy what? A definition. We have what's called alternate interior. Okay, alternate interior. So we're only going to be looking at the ones on the inside, right, for the interior? And the name gives it away. I love that about the name. It gives it away. All right, so what is this definition? It's the following. Two non-adjacent angles in the interior that are on, get this, alternate sides of the transversal. I always tell people it makes a Z shape. Now, think about this. 1 and 3, are they on alternate sides of the transversal, right? But the problem is 1 and 3 are what? So what's left for 1 to go with? Yeah, so you get angle 1 and angle 4 are a pair. And then you're going to have angle 3 and what? 5? All right, guys, let's look at just angle 1 and angle 4. Look at this. Do you see that black Z I just made? There's your Z shape. It should make a zigzag if you're making the angles. And it goes the other way around for 3 and 5. Look, here's 3 and 5s. You don't have to write it down. See the Z? Your angle, if you get that Z shape, you know you have alternate interior angles. All right, next ones. We got to stop, unfortunately. We got to keep going. Alternate exterior. Some books do not have this, some books do. I always refer to these because it makes your life easier if you know them. Alternate exterior angles are two non-adjacent angles. Guess where they're located? In the, see, you already know the definition. In the exterior that are on alternate sides of the transversal. Now, again, let's think about what alternate means here. Exterior. So my only angles that are exterior are 2 and 6, 7 and 8. Guys, are 2 and 7 alternate exterior angles? What's the problem with 2 and 7? They're on the what? Same side. So what's left then as your option? 2 and what? I always say alternate exterior easy. They're the ones farthest away from each other. They're the far sides of it. They kind of go like this. Watch my hands. This is weird. It's kind of like this. Are you guys with me? It's like good aerobics. Far away. Get it? Okay, I know. Thank you those who don't have the video. You're missing nothing. All right, anyway. Right? It's what it is. So 2 and 8, and then we got 6 and 7. Okay, I bet you guys can figure this one out. Same side interior angles. So there's my interior angles. We only have 4 to choose from. I have to be on the same side. You probably can pick out the pairs before I even write the definition, but let's write the definition. There are going to be two non-adjacent angles in the, get this location, interior on the same side of the transversal. Okay, guys, using that definition, what angles? 1 and what? 1 and 5 and what? Angle 3 and 4. Now, this makes a weird shape. It makes a rough C, by the way. It's a kind of a boxy C. It will either look kind of like this when you're working with it. If you look at 1 and 5, notice the boxy C shape that you get. It's the kind of the idea that helps you pick them out. All right, now let's see if you guys can rock this. All right, let's see if we can pick these out. Use the name of it, really is its definition, isn't it? The key was make sure they're always not adjacent, and you've got this probably down. Probably got it down. All right, so guys, what's my transversal in example 3? Which line's my transversal? Z, all right? So Z is my transversal. Everything's based off of that. All right, I'm going to highlight interior just so we know interior. There's my interior. There's my exterior. Sound good? All right, I need a pair of corresponding angles. Who can give me a pair of corresponding angles? Cora. Angle 2 and angle 4. Like it. Angle 2, and now I'm assuming a lot of you did not agree with Cora and you had a different pair, right? Anyone else have a different pair than that? David, do you have a different pair? Yeah, angle 7 and angle 5. Guys, how many could I possibly write down? How many pairs do we have for corresponding? 4. I'm only putting 2 down, so does that mean, think about what grading's like for me. Are you starting to feel, you need to be nice to me, because I have to grade a lot. All right, I need a pair of same side interior angles. Who's got this one for me? Katie? Yep, right on. Angle 2 and angle 3. All right, can I have another pair? Come on, there's only one other pair. Come on, Hannah, help me out. What other pair would I have? Yep. All right, pair of alternate interior angles. Who's got alternate interior angles for me on this one? SJ. Said 2 and 6. Thank you for making that pretty Z shape for me. Angle 2 and angle 6. Trevor, was there another pair?
I forgot.
All right, but think about it. If there's 2 and 6, what would be my other pair? See, you knew there was another pair. I knew that. Angle 7 and angle 3. Awesomeness. Pair of alternate exterior angles. Just remember the arm movements. It works really good. Alternate exterior angles. Rebecca, do you think you got one for me on that? Perfect. Now, honestly, you don't have to write all of them down, but do you guys agree with me? Angle 8 and angle 4 would be your other option. The only one I could write more for would be A. All right. This has been known to show up in quizzes and tests. My eye's hurting a little bit by the wings, but hopefully people are catching on to what we need. All right, now it says a few things here. It says, name the 2 lines and the transversal that form each pair of angles. Then classify the pair of angles. So let's do it like this. I think it's easier to name the transversal first, then name the lines, and then name what type. Are you guys with me that? So let's do transversal first, lines, transversal. I'm going to write this down so I don't forget to do it. And if the bell rings, we can fill it in quickly. All right. But we need to name what type. All right. 2 and 5. The first thing you do when you look for these, and it's crazy like this with all those lines, is you look for the one line that makes both of them. Guys, what's the one line that makes both 2 and 5? Angle T, right? I mean line T, angle T. Where did that come from? Line T. That's your transversal. The one line that makes both angles is considered your transversal. All right, now what 2 lines does the transversal intersect? That would be lines what? M and, isn't that M and K? So we got lines M and K. What type of angles, if this is my transversal, and I'm just going to highlight it for a moment and then I'll erase it. There's my transversal. I'm looking at 2 and I'm looking at 5. Ask yourself the question, are they on alternate sides? They're corresponding because they're on the same side. One's exterior, one's interior, and they're non-adjacent. Perfect, guys. I love it. You guys saw it right away. Corresponding angles. Awesomeness. All right, angle 5 and angle 10. What is the line that makes both angle 5 and angle 10? Tyler, can you help me out? Because if this is 5 and 10, isn't that the line that makes both of them? So it's line what? Line K, right on. So we got line K. I have to make mine a cursive K because my lowercase k's aren't any different than my capital. All right, what two lines does that transversal intersect? Lines M and T, right? Make sure you lowercase letters when you're naming lines. What type of angles are those? If I'm looking at 5, yeah, because they're on the same side, and they are between the two lines that the transversal is intersecting, so it's same side interior. Do you see how these really, the names give away what you're looking for? My biggest pet peeve is when people can't write the definitions of these down, considering corresponding is the only one that's not very helpful. The rest, the line tells it all, doesn't it? All right, who's got 2 and 10 for me? 2 and 10. What is my transversal? 2 and 10. Claudia. You said line M. Perfect. This is one right here. So we got our transversal is line M, which means my other two lines are the ones that are intersecting. So we know that our lines T and K. 2 and 10, guys. What shape do they make? The Z shape, which means they're alternate what? Alternate. Notice my abbreviation. Do you have permission to abbreviate like that as well? Guess what? Yes, otherwise you're writing forever. So alternate interior angles. All right, last but not least, 6 and 7. 6 and 7. What's my transversal? Yep, so we have line T. That means my other two lines are the ones that are being intersected. So lines M and K. And what type of angles are 6 and 7? It's the arm one, right? Opposite, farthest away, alternate exterior. What do you guys think? Does it make sense? All right, some hints on this one. Always look for a transversal first. Are you guys with me on that? Number 2, you can never use more than 3 lines, okay? You have to have a transversal and 2 intersecting lines. If you somehow are looking at 2 angles and you have 4 lines involved, they don't count. Also, this is something that's really mean. Memorize all of today's what? Definitions, my friends. You've got to know them all very, very well. Homework. You got your calendar when you guys walked in, correct? I think I wrote it on the board as well. It's very similar to what we've been doing. It's a lot of it's just naming and identifying. And there's a little bit of review on vertical angles and linear pairs. Homework is still expected to be submitted on time. I know it's homecoming week, but this isn't one of those that is really that bad. I think you guys will survive it pretty well. Any questions? Are we good?